Io is one of Jupiter's four large Galilean moons, and it stands apart as the most volcanically active world in the entire solar system. Its surface is alive with hundreds of volcanoes, some shooting plumes of molten sulfur and gas more than 300 kilometers high. The colors that paint its surface, yellows, reds, and blacks, come from sulfur compounds constantly reshaped by eruptions. Unlike Earth's moon, Io's surface never stays still for long. Every eruption transforms its landscape, covering old craters and creating new plains of frozen lava. This restless activity is driven by Jupiter's enormous gravity. As Io orbits, Jupiter's pull stretches and squeezes the moon's interior like a stress ball. The friction from this tidal flexing creates immense heat, melting rock deep below the surface and fueling non-stop volcanic activity. NASA's Juno spacecraft, currently studying Jupiter and its moons, has been capturing stunning new images and measurements, revealing that Io's eruptions are far more frequent and powerful than previously thought. It's a world in constant chaos, one that shows how dynamic and violent the outer solar system can be. Beneath Io's colorful, craterless surface lies a world of molten fury. NASA scientists believe that just below its crust is a global ocean of magma, a layer of liquid rock kept hot by Jupiter's relentless gravitational pull. As Io orbits the gas giant, the moon is tugged not only by Jupiter but also by the nearby moons Europa and Ganymede. This constant gravitational tug-of-war bends Io's interior, generating friction and heat powerful enough to melt rock. The result? A world that never cools down. Volcanic vents burst open constantly, spewing out lava hotter than anything found on Earth, some reaching temperatures of 1,600 degrees Celsius, 2,900 degrees Fahrenheit. Massive plumes rise into space, leaving trails of sulfur gas that form a thin, toxic atmosphere. From space, these eruptions look like glowing beacons flickering across a living surface. Data from NASA's Juno mission and previous Galileo flybys show that Io's heat output is about 100 times greater than Earth's. It's as if the entire moon is being cooked from the inside out. Scientists describe Io as a laboratory of planetary chaos, a natural experiment in how gravity, heat, and motion shape worlds beyond our own. When NASA's Voyager spacecraft first flew past Io in 1979, scientists were stunned. Instead of an old, cratered moon, they found a world alive and changing. Io's surface looked like a painting splashed with yellow, orange, red, and white. Colors shaped by sulfur, sulfur dioxide frost, and molten rock. What they were seeing was the most volcanically active surface in the entire solar system. Today, thanks to the Galileo orbiter and NASA's ongoing Juno mission, we know just how extreme this world truly is. More than 400 active volcanoes erupt across Io's surface. Some shoot fountains of molten lava hundreds of kilometers high, while others spread vast glowing lakes of fire. The largest volcano, Loki Patera, is so massive that it brightens and dims like a lighthouse. A cycle scientists believe is caused by the crust of a huge lava lake, collapsing and reforming. Unlike any other moon, Io has no impact craters. Its constant eruptions erase old marks and create new ones, meaning its surface is geologically young, constantly rebuilding itself. From orbit, Io looks alive, as if it's breathing fire. Through each observation, NASA's scientists learn not just about Io, but about the forces that can reshape entire worlds, including our own. Io's fiery personality comes at a cost. It's locked in a deadly dance with the giant planet Jupiter. Every second, Io feels the crushing pull of Jupiter's immense gravity, along with the smaller but powerful tugs from its neighboring moons, Europa and Ganymede. This constant tug-of-war stretches and squeezes Io's rocky interior like taffy, creating immense tidal heating. That's the secret engine behind Io's endless volcanoes. But gravity isn't the only force at play. Io also orbits deep inside Jupiter's magnetic field, the most powerful in the solar system. As Io moves through this field, it acts like a giant electrical generator, producing up to 400,000 volts of electricity. This interaction creates massive auroras on Jupiter's poles and forms a donut-shaped cloud of charged particles known as the Io plasma torus that wraps around the planet. However, this environment is incredibly dangerous. The radiation near Io is so intense that it could kill a human in minutes. Even robotic probes must be shielded to survive. Yet, within this deadly system, Io helps shape Jupiter's magnetosphere and drives complex electrical currents that connect moon and planet in ways scientists are only beginning to understand. In short, Io doesn't just orbit Jupiter, it powers it. For decades, our view of Io came from fleeting flybys, brief, blurry glimpses from Voyager, Galileo, and New Horizons. But everything changed when NASA's Juno spacecraft began orbiting Jupiter in 2016. Originally designed to study the gas giant itself, Juno has become one of our best observers of Io's fiery world. Starting in late 2022, Juno began a series of close flybys, some passing less than 1,500 kilometers from Io's surface. Its powerful instruments captured incredible high-resolution images, showing active lava flows, glowing hotspots, and dramatic changes over time. These aren't ancient scars, they're living volcanoes, reshaping the moon's face almost in real time. Infrared data from Juno revealed temperatures exceeding 1,200 degrees Celsius, and patterns suggesting new eruptions that hadn't been seen before. It even detected plumes rising hundreds of kilometers high, proof that Io's volcanic power is still raging. Scientists believe these ongoing eruptions are windows into how planets release internal heat and evolve over billions of years. By watching Io, we're also watching Earth's ancient past, when our own planet was just as active and chaotic. Juno's mission has turned Io from a distant mystery into a dynamic, living world. A reminder that even in the cold reaches of space, fire still burns. Io's story is far from over. In fact, scientists believe we've only scratched the surface. Quite literally. Each new mission to Jupiter reveals something unexpected about this volcanic world. The future of Io exploration isn't just about admiring its beauty, it's about understanding the violent forces that shaped our solar system. NASA plans to continue using Juno's extended mission to monitor Io through 2025, collecting even more detailed infrared and magnetospheric data. Beyond that, future missions like Europa Clipper and the European JU ICE mission will also observe Io from afar, studying how its eruptions affect Jupiter's powerful magnetic field and nearby moons. But perhaps the most exciting idea is still on the drawing board: a dedicated Io observer. Scientists have proposed sending a spacecraft that could orbit Io itself, something never done before, to watch volcanic eruptions as they happen, and maybe even map the moon's thin atmosphere in real time. Io also pushes planetary science to its limits. Its heat, radiation, and constant activity make it one of the most challenging places to explore. Yet, it's these very extremes that make it invaluable. Understanding Io could teach us how worlds die, how new surfaces form, and even how volcanic activity drives planetary change across the universe. The fires of Io may never die out, and as long as they burn, humanity will keep watching, learning, and reaching farther into the unknown. Io is more than just a moon orbiting Jupiter. It's a window into the deep, fiery heart of our solar system. Every eruption on its surface tells a story written in molten rock and cosmic energy. For scientists, Io is a living experiment, one that helps us understand how planets form, evolve, and ultimately change over billions of years. But Io's importance goes beyond science. It reminds us how dynamic and unpredictable the universe truly is. A world that constantly destroys and rebuilds itself challenges our understanding of stability and permanence. In Io, we see both creation and chaos existing side by side. A reflection, perhaps, of the same forces that once shaped Earth. For humanity, Io stands as a symbol of curiosity and resilience. It pushes us to explore places where no life can survive, simply to understand what lies beyond. The technologies we develop to study such harsh environments, from heat-resistant spacecraft to advanced sensors, will one day help us survive on other worlds. When we look at Io, we don't just see a volcanic moon. We see the restless spirit of exploration. The same drive that took us to the moon, to Mars, and now to the edges of Jupiter's realm. Io reminds us that as long as we keep asking questions, the universe will keep giving us new mysteries to chase.